Well, howdy. So, why did two fours skip lunch? Because they'd already ate. Okay. What is the butterfly's favorite subject in school? Yeah, it's mathematics. Yep. Okay. Yeah, okay. Let's get on with it.
Slide to the right.
That's a translation.
Turn around.
That's a rotation.
Flip it over.
That's a reflection. And these are all called transformations. A flip is a reflection. A slide is a translation. A turn is a rotation. Let's turn it around. A flip is a reflection. A slide is a translation. A turn is a rotation. Let's turn it around.
Slide to the right.
That's a translation.
Turn around.
That's a rotation.
Flip it over.
That's a reflection. And these are all called transformations. A flip is a reflection. A slide is a translation. A turn is a rotation. Let's turn it around. A flip is a reflection. A slide is a translation. A turn is a rotation. Let's turn it around.
Let's talk about symmetry, okay? Flip the shape, but the first one stays. A mirror reflection is what you see across a line of symmetry. Across a line of symmetry.
A flip is a reflection, a slide is a translation, a turn is a rotation, let's turn it around. A flip is a reflection, a slide is a translation, a turn is a rotation, let's turn it around.
Let's look at one last transformation by watching this shape take on a new formation. Same shape, different size and location. The name for this is a dilation. The sides of each shape have the same ratios. The wrinkles are identical, they're on the nose. So to sum it all up in my finest prose, a reduction is small and enlargement grows. Dilations need a scale factor, that's a ratio, defining how much a shape will shrink or grow. And there needs to be a fixed center point, so we know that all points through it must go. We see dilations everywhere we go. They're different sizes of the same logo. We see them when we enlarge a photo. You'll probably see them all the time now that you know.
A flip is a reflection, a slide is a translation, a turn is a rotation, let's turn it around. A flip is a reflection, a slide is a translation, a turn is a rotation, let's turn it around.
Reflection. Rotation. Translation. There are three basic transformations that can be done to a shape: reflection, rotation, translation. These transformations move the shape without making any changes to its shape or size. Reflection. A reflection flips a shape over to create a mirror image. In this example, the triangle on the right has been reflected, flipped over the dotted line to create a mirror image. Or we can say that the vertices of the triangle A, B, and C has been reflected, flipped over the dotted line to create the mirror image as another triangle having vertices A dash, B dash, and C dash. Notice that the second figure, which is called the image, is exactly opposite the original figure. You can remember this because when you look in a mirror, you see a reflection. but you are seeing a mirror image in which everything is opposite. If you have writing on your shirt, it's backwards in the mirror. Notice that the dotted line is called the line of reflection. It is also sometimes referred to as the axis of reflection or the mirror line. Can you see how the original point A and the new point A are the exact same distance, 3 units, from the line of reflection? The same is true for point B's 1 unit away and point C's 3 units away. Whenever a shape is reflected, each set of the corresponding must be the same distance from the line of reflection. We see reflections all the time in real life. Obviously, we see them in mirrors, but they also occur in water. When a reflection occurs in water, however, it is not a technical, mathematic reflection. Why not? Because the image in the water is normally somewhat distorted. It is not the exact same size and shape. Rotation. A rotation turns a shape. In this example, the triangle has been turned or rotated. Sometimes shapes are rotated just a few degrees, and other times they may be rotated significantly. In this example, the triangle was rotated counterclockwise. Whenever a rotation occurs, the figure must always stay the same size and the same shape. It is only turned. There is always a point about which the shape is turned, like the center of a clock, about which the minute and second hands move. In our example, that point is marked with the crosshairs. If a figure is rotated all the way around, back to where it started, this is called a full rotation and is 360 degrees. Halfway around is 180 degrees. When a figure is rotated exactly 180, it is said to have point symmetry because each point has a matching point that is the same distance but in the opposite direction. Translation. A translation moves or slides a shape. In this example, the rectangle has been translated, moved, or slid. Or we can say that the vertices of the rectangle A, B, C, and D have been translated, moved, or slid to the points A dash, B dash, C dash, and D dash. The new rectangle, called the image, has been moved up and to the right. A translation always moves an object, but it does not turn it, flip it, or change its size. Each point is moved the same exact distance and in the exact same direction. In our example above, each point was moved 9 spaces to the left and 4 spaces up. Determine whether each picture represents a reflection, rotation, or translation. This is a translation because the octagon has been moved or slid. This is a reflection because the triangle has been flipped over the line. This is a rotation because the figure has been turned. Let's see what you have learned in this lesson.